morning. We will move to the next chapter, light, reflection and refraction. So in this chapter we will discuss about refraction of light, reflection of light, image formed by concave mirror, convex mirror, convex lens, concave lens. Then what will happen when light passes through a glass slab? All those things we will discuss in this chapter. Okay. So before starting the chapter, you know what is light? You will say, yeah, light is there. We are able to see things around us because of light. If we are in a dark room, we can't see anything in that room. So, if light is there, then we will be able to see objects around us. Or we will be able to see the beautiful world around us if light is there. Then what is light? Actually, light means it's a form of energy. It's a form of energy that produces the sensation of sight. That produces the sensation of sight. That is light. It's a form of energy that produces the sensation of sight. Now, how we will be able to see things around us? Actually, the light will fall on that object and it will be reflected back. And if that reflected light is received by our eyes, then we will be able to see that object. Light should fall on that object. It will be reflected back. If that reflected light reaches our eyes, then we will see that object. Okay. So, light is a form of energy that produces the sensation of sight. An object reflects light that falls on it. The reflected light, when received by our eyes, enable us to see things. You know, light travels in a straight line. In lower classes we studied about that. That is known as rectilinear propagation of light. That is known as rectilinear propagation of light. Light travels in a straight line. Then, characteristics of light. It's an electromagnetic wave. In class 9 we studied about sound. It's a mechanical wave and it needs a medium for its propagation. Sound cannot travel through vacuum. It needs a medium for its propagation. That medium can be air, water or solid. Means solid, liquid or gas. But for light, it's an electromagnetic wave. It doesn't need a medium for its propagation. It can travel through vacuum. Next important thing is the speed of light in vacuum is 3 into 10 raised to 8 meter per second. 3 into 10 raised to 8 meter per second. Normally we will denote it by a letter C. Small letter C. That letter is used to represent the speed of light in air or vacuum. It travels in a straight line, that is known as rectilinear propagation of light. Then, normally an object which emits light is called a source of light. We know sun is our source of energy, ultimate source of energy. Sun is also a source of light. a lighted candle, an electric bulb, with all these will emit light. So that can be considered as a source of light. A burning candle can be considered as a source of light. An electric bulb, which is in the on state, can be considered as a source of light. Normally, we represent the ray of light. Means the light travels in a straight line with an arrow head. That arrowhead represents the direction of the light ray. In which direction it is traveling or moving. Okay. So that's a ray of light. Okay. So here convergent beam is there. Convergent beam of light means here so many rays of light is there. It will converge to a single point. All the light rays will converge to a single point. So that type of light rays are known as, or beam is known as convergent beam of light ray. Okay, convergent beam of light ray. Beam of light means it's a bundle of light rays. Okay, it's a bundle of light rays. That's known as a beam of light ray. That will be moving in the same direction. Okay, it will be moving in a bundle of light rays moving in the same direction. That is known as beam of light ray. So here all these light rays are moving in the same direction and it will meet at a point. That's known as convergent beam of light ray. The next one is divergent beam of light ray. All these light rays appear to come from this point. All these light rays appear to come from this point. That's known as a divergent beam of light ray. Or these light rays are moving away from this point. The light rays are moving away from this point. One more thing I will tell you. Here, the spacing between these light rays goes on decreasing. Here, when the light ray travels from this point to this point, the spacing between the light rays will goes on decreasing. In convergent beam of light ray. In divergent beam of light ray, as the light ray is moving away from this point, the spacing between the light rays will goes on increasing. The spacing between the light rays will goes on increasing in divergent beam of light ray. Now, our topic is reflection of light. So, what is meant by reflection of light? You have studied in lower classes. Bouncing back of light from a polished surface. Bouncing back of light from a polished surface. Like mirror, metal plates. Okay. That's known as reflection of light. Okay. Bouncing back of light from a smooth polished surface such as mirrors or from metal pieces. That's known as reflection of light. So here this one is an incident ray. This light from the torch falls on the surface. That is an incident ray. Then this one is a reflected ray. And this reflected ray reaches our eyes. Then we will see that object. So the direction of this ray is changed. The mirror actually changes the direction of the ray of light that falls on it. A mirror will change the direction of the light ray that falls on it. So this light ray is falling in this direction. This mirror will reflect in that direction. So the mirror will reflect in that direction. That is it changes the direction of light ray that falls on the mirror. Now, next thing is, so many important terms are there related to the reflection of light. First one is the incident ray. The ray of light which falls on the mirror's reflecting surface. That is the incident ray. Here, this line is the incident ray. This is the mirror and this ray is falling on the mirror. That's AO. That represents the incident ray. Then, this is a reflected ray. OB. That is a reflected ray. The mirror will change the direction of the light ray that falls on it. Now, this point O, that point is known as the point of incidence. That is known as the point of incidence. Point of incidence. The point at which the incident ray strikes the reflecting surface of the mirror. That's known as point of incidence. Point of incidence. Normal. The normal is a line drawn at right angle to the mirror surface at the point of incidence. The normal is a line drawn at right angles to the mirror surface at the point of incidence. So, this point O. At this point, the incident ray meets the reflecting surface. So, that is known as the point of incidence. This point. That's a point of incidence. The reflecting incident ray will meet the mirror surface. Now, if you draw a line perpendicular to the reflecting surface at this point of incidence, then that is the normal. Means a 90-degree line you draw on the mirror's reflecting surface at the point of incidence. That's a normal. Then, angle of incidence. The angle with which the incident ray makes with the normal at the point of incidence is denoted by the letter, small letter I. The angle between the incident ray and the normal. Angle between the incident ray and the normal. So, this angle. That angle represents the angle of incidence. That angle represents the angle of incidence. Next one is angle of reflection. The angle with which the reflected ray makes with the normal at the point of incidence means angle between the reflected ray and the normal. Angle between the reflected ray and the normal. This angle. That angle is known as this angle. That is known as the angle of reflection. So, incident ray, the ray which falls on the mirror. Then, point of incidence, where the incident ray meets the reflecting surface. At which point? That point is known as a point of incidence. From there, the ray will be reflected back. That is known as a reflected ray. The normal means a line drawn at 90 degree to the mirror surface at the point of incidence. Then, angle of incidence, angle between the incident ray and the normal, angle of reflection, angle between the reflected ray and the normal.
Angle of reflection, that is the angle between the reflected ray and the normal. So, this angle, this is a reflected ray and this is the normal. So, this angle that is known as the angle of reflection. It is denoted by the letter, small letter r. This angle between the reflected ray and the normal, that angle is known as the angle of reflection, and that is denoted by the letter, small letter r.